Hello everyone, welcome back to our class. We discussed previously wave function equations. Once again we will see that equations. Okay, we recall now. Y of x comma t equals to f of x minus vt. This wave function represents the wave pulse moves in positive x direction. Positive x direction. Okay, now y of x comma t is equals to f of x plus vt. This wave function represents negative x direction, right? These two equations represents which is the wave pulse is moving in the different directions on the x-axis. Already previously we discussed these equations, we have written on the board. Okay, now the wave function, mostly the wave function, in order to wave function represents traveling wave. The wave function represents traveling wave. Okay, it represents a traveling wave. Three quantities which are x, comma, v and t. The quantities, three quantities are which are x, comma, v and t. Okay, almost there appears to combination x minus vt or x plus vt. X minus vt or x plus vt. Right, these three quantities, which are the quantities x, v and t. Okay, the mostly appears to combination x minus vt or x plus vt. So here is x minus vt. Like this, some example of these equations. They are traveling wave equations. I am giving some examples, okay, based on the concept x minus vt or x plus vt. Here is, for example, x minus vt whole square. It's y is equals to x minus vt whole square. Y is equals to root x minus vt. And next, y is equals to a e to the power of minus b of x minus vt whole square. Okay, these all waves are represents traveling waves. Okay, they are traveling waves. Traveling wave. If y is equals to x minus vt, x square, v square, t square, y is equals to root x minus root v into t, y is equals to a e to the power of minus b x minus v square t. They are not represents wave function or traveling waves. Okay, not traveling waves. Traveling waves. Okay, now y is equals to x square minus v square t square. Either we take y is equals to root x minus root v into t, y is equals to a to the power of minus b of x minus v square t. So like these equations, not traveling waves. Today we are going to discuss the main important key points in this class, or key points. Okay, already we discussed the wave function equations in previous class. Today means in this class we are going to discuss these points. JEE Pro J, it is the shortcut name. JEE means general wave equation. Differential wave equation. Differential wave equation. Progressive wave equation. General expression for a sinusoidal equation. Okay, now we are going to discuss about these points. The first one is general wave equation. General wave equation. Okay, what is general wave equation here? The wave function, space and time mostly appears to be a wave is ax plus or minus bt. Right? Ax plus or minus bt. Ax plus or minus bt is a phase wave traveling or traveling wave function. Okay, if ax minus bt, if ax minus bt is represents wave moves in the positive x direction, positive x direction. If ax plus bt, which is represents the wave is moves in the negative x direction, negative x direction. So the wave traveling equation is given by f of ax plus or minus bt. Here is how the wave is propagates in along the x direction, like this. X, this is y. X is the distance, y is the displacement. Here is the wave is moves along the x direction. The shape of the wave does not change when it propagates along the x direction. Shape, how much shape here is there? Same as that of shape here. Same as that of shape here. So the shape of the wave does not change when it is moves either in x direction or in negative x direction along the x axis. That's why here is the wave function is y is equals to f of ax plus or minus bt. The speed of the wave, it has to be certain speed when it moves along the x direction. Speed v. V is equals to coefficient of t is divided by coefficient of x. coefficient of t is divided by coefficient of x. So what is the value of coefficient of t here? B. That is b by the coefficient of x is a. B by a. The speed of the wave is equal to b by a. Write these points. In the another way, we have to write the speed of the wave. When the wave moves along the positive x direction or either in the negative x direction, the shape does not change. Now I told you the shape does not change when it propagates along the x direction. So here is when ax plus or minus bt is constant. It is constant. Now a dx by dt plus or minus b, that is equals to 0. Okay, differentiate x with respect to time. A of dx by dt plus or minus b is equals to 0. Here is dx by dt. Dx by dt is nothing but a rate of change in distance, that is the speed. A v plus or minus b is equals to 0. Here v is equals to b by a. Okay, here plus or minus also we should indicate here either plus b by a or minus b by a. So the speed of the wave v is equals to plus or minus b by a. When the wave shape does not change, okay, it is constant. When it is constant, then we have to prove the speed of the wave v is equals to plus or minus b by a. So the wave moves along the x either in positive direction or in negative direction. Now what is the general equation? The general equation is y is equals to f of ax plus or minus bt. That is the general traveling wave equation. The example of wave traveling equations are y is equals to a sine omega t minus kx, y is equals to a cos square ax minus bt, y is equals to a by b plus ax minus bt whole square, y is equals to a e to the power of minus of ax minus bt whole square. Like these equations are represents traveling waves. They are represents traveling waves. If y is equals to a sine kx omega t, next y is equals to here a e to the power of minus of a square x minus bt, they are not represents wave traveling equations. So now we are going to discuss about differential wave equation. Differential wave equation. So we have to derive the differential wave equation here from the traveling wave equation is y is equals to a sine omega t minus kx. when the differentiation of this displacement wave del y by del t, that is equals to with respect to time, you know, del y by del t a omega cos omega t minus kx, del square y by del t square is equals to minus omega square a sin omega t minus kx. Again, differentiation of y with respect to x, del y by del x is equals to k a cos omega t minus kx. Here is minus omega square is considered k, a cos omega t minus kx. Sign differentiation is cos here, omega t minus kx. Del square y by del x square is equals to minus k square a sin omega t minus kx. So this is a second equation. The first equation is, here it is the first equation, 1 is divided by 2. Equation 1 is divided by equation 2. So what is the first equation here? Del square y by del t square is divided by del square y by del x square, which is equal to minus omega square a sin omega t minus kx is divided by minus k square a sin omega t minus kx. Here is minus omega t minus kx get cancelled, a get cancelled, minus get cancelled. Del square y by del t square is divided by del square y by del x square is equals to omega square by k square. Okay, write these points. Next, del square y by del t square equal to omega square by k square into del square y by del x square. Here del square y by del t square is equals to v square del square y by del x square. This is the differential form of wave equation. Here v is the speed of the wave. Since v is equals to omega by k, v square is equals to omega square by k square. From a wave traveling equation, we know from traveling equation, wave equation, y is equals to a sin omega t minus kx. So how to find out the speed here? Find speed. The speed v is equals to, here is omega by k. Because of the coefficient of t term is divided by coefficient of x term. That means that is v is equals to omega by k. It is the speed. So here is there already. This is the differential traveling wave equation. Differential form of wave equation is del square y by del t square is equals to v square into del square y by del x square. Next one is progressive wave equation. The progressive wave equation. Progressive wave equation. So in the wave having number of particles, they are vibrating from its mean position. Okay, all the particles are executing from the mean position. It is called as harmonic progressive wave equation. That is a harmonic motion. All the particles are in harmonic motion because they are vibrating from its mean position. That's why, so that equation is known as called harmonic progressive equations. So the wave equation y is equals to a sine omega t minus kx plus or minus kx. We represents the harmonic progressive wave equation is y is equals to a sine omega t plus or minus kx because of, okay, in the wave propagation, particles are vibrating from its mean position. They are executing in simple harmonic motion. That's why the wave equation is written here y is equals to a sine omega t plus or minus kx. Its equation is harmonic progressive wave equation. Okay, where A is amplitude. We discussed already in the previous class what is amplitude. The maximum displacement of the particles from its mean position. Right? Now, omega, angular velocity or angular frequency. And here K is propagation constant. Its K is equals to 2 pi by lambda. Here angular frequency omega is equals to 2 pi n. We know that already. These equations we mentioned in the previous class. So here omega is the angular velocity or angular frequency. K is the propagation constant or wave number. K is equals to 2 pi by lambda. X is distance. Okay, distance traveling along the x direction. T is the time taken or time. This is called as progressive wave equation or harmonic progressive wave equation. Y is equals to a sine omega t plus or minus kx. Here, if y is equals to a sine omega t minus kx, if we are taking this equation is represents the wave is moves in forward direction. Okay, it's represent wave moves positive x direction. If we will take y is equals to a sine omega t plus kx, it represents wave moves negative x direction. Y is equals to a sine omega t minus kx. If we are taking this equation, this wave displacement equation is represent wave moves positive x direction. It moves in forward direction. Right? If y is equals to a sine omega t plus kx, when we are taking this equation, this is represents the wave moves negative x direction, means it is coming to backward direction. So minus of minus here, plus will come, omega t plus kx. Okay, these are the progressive wave equations which is in the direction of either in positive direction or in the negative direction. Next, the last and final key point is general expression for a sinusoidal equation. Sinusoidal equation, that is y is equals to a sine omega t minus kx plus or minus pi, or we can represent this equation y is equals to a sine kx minus omega t plus or minus pi also. So here is when the wave is moves along the positive x direction. Okay, along the x-axis the phase is represents in the positive x direction, that is initial phase constant. Here is, if we will take y is equals to a sine omega t minus kx plus pi, here where pi is phase, this is y, here is kx, okay, from here to here it is its path is taken as phase. Okay, the phase pi is initial phase constant, initial phase constant. Pi is positive initial phase constant. It is a positive initial phase constant. If y is equals to a sine omega t minus kx minus pi, kx y here is, from here to here is pi, it is negative initial phase constant, negative initial phase constant. Okay, what is sinusoidal equations? Y is equals to a sine omega t minus kx plus or minus pi. Okay, if we will take y is equals to a sine omega t minus kx plus pi, means when the wave is moves in the positive x direction, but here is along the y-axis the displacement is y, along the x-axis here propagation constant with distance of the wave is x kx. The phases takes place along the x, positive x direction, but here is above the x-axis, the phase is above the x-axis, it's considered positive initial phase constant, it is constant. Now here is when we should take y is equals to a sine omega t minus kx minus pi. Here the phases takes place below the x-axis, means here is we mentioned pi, where the pi is known as called phase, but here phase is negative initial phase constant. Here is phase is negative initial phase constant. once you check all the formulas, so which they are, these are all formulas in part 1 and part 2. So quick recall for solving the problems for useful these equations. So the first one is frequency. It is represented by n. N is equals to 1 by t. Time period, t is equals to 1 by n, where t is equals to 2 pi by omega. So the wave propagation constant k is equals to 2 pi by lambda. Wave velocity v is equals to n lambda is one of the formula, and v is equals to lambda by t is also one of the formula. V is equals to lambda omega by 2 pi, and again v is equals to omega by k. When we have written like this, since n is equals to 1 by t, we can write this formula. Since t is equals to 2 pi by omega, we have written v is equals to lambda omega by 2 pi. Since k is equals to 2 pi by lambda, the wave velocity or speed v is equals to omega by k. Here phase, the phase is represented by pi. Pi is equals to omega t plus or minus kx. Wave pulse at t is equals to 0 at the position of wave function is y of x comma t equal to f of x minus vt. When it is moves right side means the wave pulse moves in forward direction, which is in the positive x direction. Already we discussed in previous class. Wave pulse at t is equals to t at the position of wave function is y of x comma t, which is equal to f of x plus vt when the wave moves at the left side, means in the negative x direction. When three quantities which are x, v, t must appears to combination x plus vt or x minus vt. So in the formation of x plus vt or x minus vt, the wave travelling equations y is equals to x minus vt whole square, y is equals to root x minus vt, y equal to ae to the power of minus b of x minus vt whole square, etc. So many equations are there. So which are in the formation of x plus vt or x minus vt. The quantities must be in the equations which are x, v and t. That's why they are traveling waves. They are traveling wave equations. Now if which are the traveling wave equations in the form of like this, they are not a traveling wave equations. Y is equals to x square minus v square t square, y equal to root x minus root v into t, y equal to a sine of 6x square minus 16 t square, etc. They are not in the form of combination x plus vt or x minus vt. So they are not traveling waves. Next variable appears in the combination ax plus or minus bt, then the general traveling wave equation y is equals to f of ax plus or minus bt. Okay, so when appears variables, we have written like this: ax plus or minus bt. The general equation can be written as y is equals to f of ax plus or minus bt. Speed of the wave v is equals to coefficient of t is divided by coefficient of x. Here is coefficient of t is b, coefficient of x is a. Then we can write the speed of the wave v is equals to b by a. When shape of wave does not change as the wave propagates, then the speed v is equals to plus or minus b by a. When the wave is moves, the shape of the wave does not change, it should be constant. Okay? Derivation of x with respect to t, then the speed can be written as v is equals to plus or minus b by a. When it is constant, we have written like this: y is equals to a sine omega t minus kx, y equal to a cos square of bt minus ax, y equal to ax plus bt whole square, y equal to a by b plus ax minus bt whole square. So next one is y is equals to ae to the power of minus of ax minus bt whole square, etc. Okay, these are completely traveling wave equations which are in the formation of y is equals to f of ax plus or minus bt. Here is written all they are traveling wave equations. If y is equals to a sine kx cos omega t, y equal to a sine of ax square plus bt, etc. Some equations which they are not in the form of y equal to f of ax plus or minus bt. That's why in the question, if they are like this, equations are will give, they are not in the formation of wave equations. Here is written are not traveling wave equations. So which are not traveling wave equations? Where they are like this in the formations. They are not traveling equations. The different wave equations, the differential wave equations, or the differential wave equation is del square y by del t square equal to v square del square y by del x square. Progressive wave equation or harmonic wave equation is represents y is equals to a sine omega t plus or minus kx. Or if omega is equals to, we'll take 2 pi n. If we'll take the propagation constant k is equals to 2 pi by lambda, then it can be written as y is equals to a sine 2 pi n t plus or minus 2 pi by lambda into x. When the wave moves in positive x direction, then the progressive wave equation can be written as y is equals to a sine omega t minus kx. When the wave moves negative x direction, then the progressive wave equation can be written as y is equals to a sine of omega t plus kx. Okay, the last and final equation, sinusoidal wave equation is y is equals to a sine of kx minus omega t plus or minus I. By depending all these formulas, we have to solve problems in the next video. So all the students, you should see in previous part 1 video and part 2. So after completion of these equations, formulas, okay, we will use for solving the problems. Okay, thank you.